Do you want to boost your brain's performance, even your memory? The secret might be here, right at your fingertips. And this strange figure, Penfield's Homunculus, this guy might be able to show us the way. Here's a surprising question for today's video. Can your fingertips and lips actually make you smarter? Let's explore what your hands, face, and brain might be hiding about how we learn. Our new friend is drawing something on a piece of paper. If you want to find the secret of learning, stay with me. The ideas of today's video are based on 3 scientific articles. You will find their titles in the video description. And this strange figure, Penfield's Homunculus. Together, these sources might help us uncover some fascinating facts about memory and about how learning really works. Hi, I'm Fad. Welcome to Everything Under and Beyond the Sun. Have you ever seen that weird little man with giant hands and a huge mouth? It's Penfield Homunculus, a brain map that shows how your brain sees your body. It might be hiding a secret about how we learn. Today, we are diving into a question that sounds simple, but opens up a complex world. Can your fingertips actually make you smarter? Can touching, writing, tracing, or feeling with your hands improve your focus, memory, or learning itself? Neuroscience says yes, and it all starts with the way your brain is wired. The Penfield Homunculus is a figure showing how much brain space is dedicated to each body part. Let's start by introducing Penfield's Homunculus, a bizarre yet brilliant map of your brain. In the 1940s, a neurosurgeon, Wilder Penfield, was performing brain surgeries on awake patients. When he stimulated parts of cerebral cortex by electric current using tiny electrodes, patients reported that they felt sensations in specific body parts. From this, Penfield discovered something fascinating. The brain does not map the body evenly. Instead, regions of the brain are dedicated to different body parts based on sensitivity and motor control, not size. That's why in the homunculus, hands and face are huge. Think of how precisely you use your fingertips to thread a needle, and how subtle lip movements shape your speech. In contrast, areas like the back take up very little brain space because they are less sensitive and less involved in complex motion. But here is something even more surprising. In the brain's cortical map, the palms of the hands and face areas are right next to each other. Even though your hands and your face are physically far apart, their neural representations are side by side. So your fingertips and lips take up far more brain space than your arms or back. And as mentioned before, their corresponding regions on the brain are next to each other. This strange layout reveals deep functional relationships, like how newborns use both hands and mouth for exploring the world, or how tactile stimulation of the fingers may affect speech and memory. Now, here is something fascinating you can actually try. What if, while reading, you touch the words with your fingertips and at the same time quietly recite them with your lips? It may sound simple, but this small action can actually have a powerful effect on your brain and the process of learning. When you do this, you are activating multiple brain areas at once, all located next to each other in your brain sensory area. Your fingertips, lips, and tongue occupy huge neighboring regions in your brain, to be exact, in the somatosensory cortex. So, when you touch and speak at the same time, you are creating neural synergy, engaging adjacent areas of your brain in a coordinated way. This kind of multisensory learning, combining speech and touch, can strengthen memory, deepen concentration, and make the material more personally encoded. It's the same principle behind why children trace letters while learning to read, and why Braille readers develop exceptional tactile memory. Some studies show that tactile learning from fingers can transfer to improved perception in the face, because those regions are neighbors in the brain. During the rest of this video, we will explore these studies and examine the process of learning. People who engage their fingers intensively, like musicians, Braille readers, or those who write by hand, often show superior tactile memory and neural sharpness. That's because the act of using your hands isn't passive. It builds deeper connections in your brain. Just a quick note to mention. I will be using the term blind for clarity and simplicity in this video. I understand that visually challenged or visually impaired might be more appropriate or politically correct in formal contexts, but I mean no offense. So, in people who are blind, especially those who are blind since birth, the brain doesn't just compensate by sharpening hearing and touch. It rewires itself completely. In blind people who read Braille, the part of the brain which is normally used for vision is rewired to interpret information received through touch or tactile inputs. In other words, that part starts processing tactile inputs instead of processing visual information. To get a better sense of the issue, let's look at what some scientific studies have found. A study was done in 2002. Its title is Adaptive Changes in Early and Late Blind, a fMRI study of Braille reading. It showed that even in people who lost their vision later in life, reading Braille activated the visual areas of their brain. During this study, a remarkable fMRI was done, which showed something astonishing. When blind individuals read Braille, they don't just use their fingers. they use their visual cortex, the part of the brain normally responsible for seeing, not touching. That's right. In blind Braille readers, the visual cortex lights up when they read through touch. So, your fingertips, they aren't just sensing the word. They are somehow reprogramming your brain. This is called cross-modal plasticity. It's the brain way of saying that if one sense goes silent, another will speak in its place. And it doesn't stop there. The earlier the blindness, the more intense this transformation. In those blind since birth, the visual cortex becomes deeply involved in processing touch, as if it was always meant to be part of that system. So, what does it mean for the rest of us? It means that our brain is far more flexible than what we often assume. And more importantly, it shows that tactile learning or learning through touch, especially through the fingertips, can activate some of the brain's most powerful regions, even those regions that aren't originally meant for touch. That's the power of your hands and the power of the brain's plasticity, resilience, or flexibility. This isn't just about blind or visually challenged readers. Another study uncovers a fascinating link between how we use our fingers and the broader question of how we learn. What happens when you actually use your hands to write, not just to feel? A landmark study done in 2014 titled "The Pen is Mightier Than the Keyboard" found that handwriting beats typing when it comes to learning. In this study, students who took note by hand remembered more and understood better than those who typed on laptop, simply because typing is fast, but it encourages shallow processing. You copy things done word for word without thinking much. Writing by hand is slower, but that's the point. You summarize, reflect, and engage your mind while your fingers move. That's what leads to deeper memory and better conceptual understanding. So, that process of writing by hand, the physical movement of your fingers combined with mental filtering, leads to deeper learning. The study says even a week later, the handwriters remembered more, especially when they were asked to explain ideas, not just facts. It's a perfect example of how using your fingers in an intentional way activates the brain, not just motor area, but understanding and memory too. So it seems that your fingertips don't just help you feel the word. When you write by hand, they help you make sense of it. Now we reach at another interesting question. If I want to boost my brain performance, do I have to be learning something while using my fingers? Or is simply stimulating my fingers passively enough? Based on another study, the answer is not necessarily. It means that you can train your brain without even trying. What if your brain could learn and improve without you doing anything at all, just by using your fingers passively and engaging the sense of touch? According to a fascinating study done in 2015, this is not science fiction. It's called Training Independent Sensory Learning, or TISL. The title of the article is Evoking Plasticity Through Sensory Stimulation. TISL is a way to trigger brain's plasticity, the brain's ability to rewire and adapt, using only passive and repetitive sensory stimulation. It means your brain can learn and adapt without active practice or attention, simply by receiving repetitive and passive sensory input, like touch stimulation, for example, vibration or tapping on the skin. And it happens without you doing anything intentional. No effort, no attention, not even awareness. Imagine your fingertips being gently stimulated or tapped while you are reading, relaxing, or doing nothing at all. Over time, this simple stimulation makes your tactile sense sharper, your reaction time faster, and your motor skills better. But the impact goes far beyond touch. It can reverse age-related decline in elderly people. In stroke patients, daily fingertip stimulation led to better hand control and faster recovery, even years after the stroke. In this study, participants had their fingertips gently tapped. After a few hours, their touch sensitivity improved by 15%, and brain scans confirmed structural changes in the somatosensory cortex. It reveals the fact that your brain grows from use, even passive use. The famous expression, use it or lose it. The study also uncovers a fascinating point. It says, because the sensory regions of the hand and face are neighbors in the brain, improvements can transform from fingertips to areas like cheeks and lips, a phenomenon beautifully illustrated by Penfield Homunculus. As discussed before, it's the map of the human body on the brain that shows which parts of the cortex control which body parts. So even though your hand and face are physically far apart, their corresponding regions in the brain are neighbors. As a result of this, when one region lights up, the activity can spill over and activate nearby zones. This neural crosstalk may explain why multisensory learning, like touching and speaking simultaneously, is so effective. TISL enhances sensory learning, especially tactile perception, like detecting fine details through touch. Based on this study, while it don't directly boost verbal memory, like learning history, it improves the brain ability to process and adapt, which is the core foundation of learning. Scientists stimulated a fingertip, and surprisingly, it also improved tactile sensitivity on the face, lips, and cheeks. This shows that plastic or adaptive changes in the brain can influence or spill over to nearby regions, thanks to the specific and magnificent structure of our brain. It shows our brain isn't fixed. Touching one part can benefit others, as long as their representations in the brain cortex are close. This isn't just for the young. In older adults, even up to age 90, passive finger stimulation has been shown to improve dexterity, touch sensitivity, and even confidence. Even stroke patients show meaningful recovery when their hands are engaged. So, here is something you can try right now. The next time you are reading something, trace the word with your finger and recite them softly with your lips. You will be activating your fingertips, lips, and tongue, all major zones in your somatosensory cortex, sitting right next to each other in your brain. This creates neural synergy, a coordinated pattern that builds stronger memory pathways. Children use this method while learning letters, maybe unconsciously. Braille readers do it by necessity. You can do it by choice, and your brain will respond. Whether you are writing, playing music, or simply exploring with your hands, keep it in your mind. Your brain is listening. So, what does this all mean? It means your fingertips are not just sensors, they are teachers. In a world driven by screens and digital devices, we are quite literally disconnecting from one of our most powerful learning tools, touch. So, try using your hands, especially your fingers, again with different perspectives. Touch, write, trace, feel, speak. If you are trying to memorize a passage or really grasp an idea, don't just read it silently. Touch it, say it, feel it. Let your hands and your lips work together, and let your brain build deeper and stronger connections. Note that your brain treats those specific sensory input like gold. Your fingertips might be your brain's best kept secret. Thanks for watching Everything Under and Beyond the Sun. If you enjoyed this journey into the brain, memory, and touch, give it a like, subscribe, and share it with someone who is curious. And share your thoughts in the comments. Until next time, stay curious, stay thoughtful, and keep uncovering what's beneath and dreaming of what's beyond the sun. Thank you.